Technologies India. Today I will be hosting this webinar. So now I would like to welcome our chief guest, Dr. Joseph Teguh Santoso, Director of STEKOM University, Indonesia. And I also like to welcome our today's speaker, Mr. Ramprasad, Security Analyst, Hebesec Technologies, India. Sriram, Security Researcher, Cyber Thulir, Malaysia. And the final speaker, Setiyo Nugroho, M.Kom, lecturer in the Computer System Department, STEKOM University, Indonesia. And also, I'd like to welcome our honorable guest and audience today. Before the session starts, I would like to inform that today's session will be in the live stream and STEKOM University's YouTube channel. For today's event, we will start with the Indonesian's national anthem and continue with the next session. We will begin the main event presentation by our special speakers today and continue with the question and session. And finally, we're closing the session after taking a picture for the documentation. So first of all, we sing our national anthem. Mr. Abdul, you can start now. Thank you, Abdul. And we will go to the main event for our audience. If you have any questions for the speaker, please add them in the chat or raise your hands. We will answer some of the questions directly after each presenter has finished their session. In this session, each presenter will have a 30 minutes to present. And now let us please welcome our first presenter, Mr. Ramprasad, Security Analyst, Hebesec Technologies, India. The day is yours, sir. Mr. Ramprasad, are you available there? Okay, I would like to call upon the next speaker, Mr. Setiyo Nugroho, M.Com, lecturer in the Computer System Department, STEKOM University, Indonesia. You may present, sir.
Okay, thank you for the time, Miss Varsha. Let me introduce myself. I'm a lecturer of uh, STEKOM University, and now I would like to make a presentation about. Wait. Oh, okay. I would like to make a presentation about reinforcement learning, paradigm in learning in the machine learning. Okay, we are talking about reinforcement learning is a paradigm of the learning in machine learning. Actually, when we are talking about machine learning, basically machine learning is based on three type of paradigm or type in the learning in the machine learning. They are supervised learning, and then unsupervised learning, and then reinforcement learning. So before I go to the reinforcement learning, I would like to talk about the supervised learning and unsupervised learning first. Okay, and the first one is supervised learning. This is the how the machine learning thing, how computer think in the process of AI, in the process of detecting or processing something in the computer. First, the supervised learning. Supervised learning is the model trained on a dataset that contain input and output pair. Each input has a corresponding correct output label. Example, a cat. And the goal is learn a function that can correctly map the new input to their output based on past data. The process learning is supervised because the model is guided by the correct answer during the training. Okay, so when we are talking about supervised learning, we have to provide a data set. Data set is something that we can use it as a guide. So we have a sample of the cat, sample of photo of cat. This is the our data set, and then in the process, they supervised by our data set. Mean the process is guided by the sample or by the data set that we have provided before. Supervised learning basically about mapping input into output with label data. So one thing that we must understand in the supervised learning, there is something that we call data set, and the data set must have label. The choice of this algorithm depend on whether the problem is regression, predicting continuous value, or classification, predicting categories. So when we are talking about the supervised learning usually used for regression. we have data, we have already have a data, we already have a data, and then by computer it's processed to create uh, an answer from that data. And then the other one is to classification. We have a photo, we have you have an image, we have an image, and what is the image? What is the what is the image in this? What is the inside the image? So we compare with data set, and then when we have a match, example, the photo, the image is cat, and then we have a data set of cat. So we have the result as the image is cat. So when we use supervised learning, usually it's used for uh, classification and regression. Here we can see in this image, supervised learning usually used for regression and classification. Classification mostly being used for detect something, just like maybe object detection, object identification. When we have uh, uh, when we have a system that we need to understand what is object in front of us, and then we use algorithm of supervised learning, and then we compare with our data set, and then oh, there is a box in the front, there is a highway in our, we still on the highway, and then for in the autonomous car we can see that we still in the highway, and then we can check the image, the video, compared to the data set that there is a human in front of the car. So supervised learning is very common use for detection and classification. Also is used for regression. Regression mostly used for detect just like trend analysis by the previous data. And then when we see on the right on the right of the this monitor, there is a lot of algorithm in the supervised learning. Just like linear regression, this is the basic of predicting linear regression, and then there is a tree-based method, just like random forest, decision tree. This is most commonly well known, decision tree and random forest. And then when we are talking about image classification, usually well known in the CNN, convolutional neural network, ANN, artificial neural network, and LSTM. This is very common in the machine learning and deep learning process for detecting and classification of the object. And the other one, the first one is supervised learning, and then unsupervised learning. What is unsupervised learning? Unsupervised learning, it deal with data that doesn't have any label. We don't have any label at all. So we got a lot of image, for example, image. We have a lot of image. We give it to the computer, and the computer decide what is the image without the label. So how the process? It used for clustering. So when they have we send the computer with a lot of data, for example, image, they make a cluster. They make a cluster. This process make a cluster. This one is group A, this one is group B, this one is group C. Nah, by this process, we can get the result that this is the category. Which category is it? Which the other one is another category. So when we have unsupervised learning, the data has no label. The algorithm try to find hidden pattern, group, or structure. This is the unsupervised learning. Mostly used for clustering. For clustering. So we have a lot of data. We have a lot of data, and is mixed, is confusing, and then by this process unsupervised learning, we can make a cluster. This part is part the this data is in this part, this data in this part. So for example, in the application is we can use it for target marketing, and then customer segmentation. From the data that all the data without a label, we can make a segmentation, customer segmentation, and then we can make a recommend system by the clustering process. And then in the unsupervised learning is also can be used to dimensionally reduction the data. There is a lot of data uh, give to the computer, and then they make a classification, and then make clustering, and then make a reduction which one is useful and which one is not useful. So so by the unsupervised learning, we can make this like big data visualization. We can make from the a lot of data, we can make a visualization from the big data, and then we can make a compression of data with a meaningful. So which one wouldn't have any value, we can throw it away, and then we can make a better structure, and we can make a feature extraction. Now, there is a lot of algorithm in the unsupervised learning, just like this one, PCA, a priori algorithm, one class SVM, isolation forest. This one is well known for this unsupervised learning. And then the other one is reinforcement learning. Reinforcement learning is another machine learning type that use the computer as the agent. The computer as the agent. The agent learn by interact with an environment. The agent take action and then receive feedback in form of reward or penalty. Over time, it learn which action lead to better long-term outcome by maximize cumulative reward. This reinforcement learning is particularly suited for sequential decision making problem, where the outcome of the action may not be immediately visible and may depend on series of prior choice. The idea in the reinforcement learning, an agent and computer interact with environment by taking action, receive reward, update the policy to maximize long-term cumulative reward. And this reinforcement learning process is mostly use this kind of algorithm, Monte Carlo method, and most well known is Q learning, and I will discuss about Q learning after this. So when we are talking about reinforcement learning, it's the process just like what human do when we deal something that we really don't know what to do. We are really don't know what to do. We enter to the a building. We don't know where the exit door. So we just go turn left, fail. We return back and then turn left, turn right. Okay, this is the result is okay. And then we go straight. Okay, and then we go turn right. There is a wrong move. We return again, and then we process this again. So this reinforcement learning mean we do it with uh we do it with trial and error. We don't have any data. We don't have any data. We don't have any specification or any detailed information. Just try. If it okay, then we get a reward. If it fail, we get the penalty. Keep trying the process until it finish. So that's why reinforcement learning mostly used in the game making. And then for predicting the future. Okay, maybe I will explain it in in the in the process of Q learning. Okay, now we are enter to the reinforcement learning process. It's about learning from the result of your choice, not from being told what to do. This is what the difference between the supervised learning and reinforcement learning. When we use reinforcement learning, we don't have any data. We don't have any something what to do. We just only meet the environment and the goal. So the result is came from your choice. It's a trial and error with a goal. The computer or the agent figure out the best path to success by constantly asking based on what just happened, what that could move. So this is the example. The agent, the computer, make an action to the environment in the environment, and we get the reward, the result, and it as a state, and it record as a state, and then he try again, another one. Is it is the result is better? Is better. If it better, it will record again. Try it again. Keep try until the result is correct. So this is a really a trial and error process. So when we are talking about reinforcement learning, it's a formalized as a continuous loop of involving your four main component: the agent, the learner, and the decision maker. The agent is the learner or and the decision maker in the machine learning. It mean the computer, the learner, and then the environment. Environment is everything where the agent interact with, and then state a snapshot of current situation of the environment. Action, then action is a move made by the agent that change the state of the environment. And then reward. Reward is a feedback, immediate feedback from the environment after taking the action. It's a scalar number, a single number that tell the agent how good or bad the action was. So the agent do the action to the environment. The state is what is happened to the environment, is it correct or not? And then they get the reward. The reward uh, is the feedback. The reward is it good or bad? And then try again. What happened to the state? What is happened to the environment after we do the second process? But and then by this process we get the reward. And then try again until they get the best way to deal with this environment. The goal of this agent is to learn a policy, which is the strategy or set of rules that define which action to take in each state. So when we are talking about reinforcement learning, is is try to get the policy, try to get the way, which is a set of rule or strategy that define the action to take in the each state. So try again, and then they get the result, and try again until they get the correct policy to deal with this environment. So when we try to discuss the reinforcement learning, maybe we in the simple way to explain about the reinforcement learning is use the simplest algorithm of reinforcement learning is called the Q learning. The Q learning. What is the Q learning? Q learning is a reinforcement learning algorithm that helps an agent learn what action to take in the different situation to get the most reward in the long run. This is when we are talking about the Q learning, we have to think it like a trial and error with a memory. The agent try something, and then we get the feedback, reward or penalty, and remember which action work best in the each situation. So there is a Q table that record the result, the reward, and then by the result of the reward, we can remember, and we can remember which action that work best in this situation. This is the key idea of Q learning. First, initialize the Q table, create the Q table, choose an action, which action, and then which action that agent of the or the computer do, and then perform action, and then measure the reward. Measure the reward. After measure the reward, update the Q table, and then choose an action again. Perform the action, measure the reward, and update the Q table. Keep trying that. So on the process, the state where the agent is right now. For example, in the robot in the maze, robot in the maze in the area that being blocked by a maze. A maze is by what is called a maze. Yeah, and in English it's called maze. And a robot in the maze is in it. The state is its position, and then action. What the agent can do. For example, move up or down or left or right. And then feedback from the environment. For example, +10 for reaching the goal and -1 for hitting a wall. So when the robot turn, move up, move down or left or right, and then does he reach the goal? Does the action reach the goal, or the action and the agent reach the goal, or the agent hit the ball? If the agent reach the goal, they get 10. They get reward 10. And then if the agent fail or hit the ball, they get -1. And then we get the Q value quality. A memory that store how good is the action in this state. Yeah, this is the basic of Q learning. Okay, so when Q learning work, start with Q table, all value is 0. The agent explore by trying different action. For each, for after each action, it get reward and it update the Q value for that state. It's an action pair. Over time, the Q table get filled with the value showing the best action for each situation. For example, the maze game, robot in the maze could reach the treasure. Bad move is hitting the wall, -1, and the good move is getting the treasure, +10. At first, the robot move randomly. This is the basic of the reinforcement learning. Trial and error. Move randomly. After it learn that go left from here is bad. Going up from here give me the point. Eventually, it find the best path every time. It means it keep trying, but keep trying and then record on the Q table. Keep trying again, record on the Q table. Keep trying again and record in the Q table. And then when they have the best value of the Q table, and then that's the method, that's the path, the best path for process this action. And then see the formula of Q learning. The Q value update looks like the new Q is equal to old Q plus learning rate multiplied by reward plus faster best future Q minus old Q. It means update what I thought was good based on what reward I got and what looks promising ahead. So this is the simplify the Q formula, but this is the correct Q learning process. This is a difficult one, and I guess we cannot discuss it in this webinar. Actually, the processing like this when Q as A currently Q value, the quality of taking action A in the state of S, alpha is mean learning rate, how much the info override into out info, DR is reward received after taking action of A, the gamma is the discount factor important for future reward. Max A, Q, S, and A is the best possible Q value for the next state of S. Update the rule, out value Q is adjust toward the reward and the best future value. Okay, so what is the benefit of the reinforcement learning? Is learning by interaction, trial and error. Unlike supervised learning, need a label data, reinforcement learning directly from experience by interacting with the environment. So when we are talking about supervised learning, just like CNN or random forest or that, we need data. We need a data. We need what is called data set. Data with label. When we use reinforcement learning, we don't need that data. It's just trying by experiment, by experience. The benefit, it can adapt to dynamic and uncertain environment where the label is unavailable. And then long-term decision making. Supervised learning optimize the immediate prediction. Maybe we know about the object detection, face recognition, fake face recognition. Is use supervised learning because we need to optimize the immediate prediction. We need the fastest way to get the information. But when we use the reinforcement learning, it optimizes the cumulative future reward. So it is like learning. We try, keep trying, and then to get a better result. This is not good for immediate prediction, but is maybe better. Is suitable for program that require strategy and planning. For example, robotic, game, or resource management. And then the ability of exploration and adaptation. Reinforcement learning actively explore action instead is just fitting existing data. Just like supervised learning or find hidden pattern, unsupervised learning. So when we are talking about reinforcement learning, is active try to explore every action to get the result, not by given data, just like the supervised learning, or by only recognize the pattern, only find the pattern in the supervised. The benefit is it can discover novel solution that not obvious or not available in the data. And then it can handle complex and dynamic environment. Reinforcement learning can continuously adapt policy when environment change. The benefit more robust in the real world application like traffic control, finance, and energy management. When we are talking about reinforcement learning, because it keep trial and error. So when there is a different condition, different environment, it can adapt. It can adapt because it keep trying again, trying the process again to get the final result. So it can adapt to the environment change. And no need a large level data set. Supervised learning just like CNN or a random forest or SVM, it need a large level data set. So we have to provide the data set first. So we don't, when we use reinforcement learning, we don't have to make uh, label data set. So this is can save our times and save our process in the domain where the label are impractical. And the reinforcement learning is just like human. It's a human like learning process. It's mimic how human or animal learn. Try, error, and then feedback. Try, is it fail? Is that become feedback for us, and then we don't do the same action. If it okay, that means we could remember that this is the correct way to do this process. So uh reinforcement learning is more look like how human learn. But there is a drawback. The sample inefficiency. When we use reinforcement learning, it means need a huge number of interaction with environment before learning a good policy, before make a good policy. It means it have to try over maybe million in the for the example is maybe a million time to find the correct policy. it have to keep trying again, keep try. So this is inefficient. And then it need a computer to think more compared to supervised and unsupervised learning. It's high computational cost. And then uh, reinforcement learning maybe have over explore or over exploit. That means it's waste time. Try a bad strategy. It's wasting time. Try a bad strategy and then try another bad strategy and then try another bad strategy and then maybe in this process the process is stick to uh strategy that's not optimal because every process is try because it's trial and error. So every process is being try in handle the situation. So it might be over explore, keep wasting time in the bad strategy. And the reward design is difficult. The reinforcement learning is rely on reward function. Poor design reward may lead to reward hacking. The agent find the loophole. So, the process maybe if we don't create the reward design correctly, maybe they can do unintended behavior and then behavior try to find the best way by itself, but not in the correct way. And then it's also instability in training. It's sensitive to hyperparameter, just like learning rate and discount factor, and performance can vary greatly between run. For example, when we test, maybe this process find the best way to the reinforcement learning. They find the best way in the first step or maybe on the two step. That means it can be fast, but sometimes because it's try and error, it's keep trying and keep error. So the performance can be vary, maybe can be fast and maybe can be really slow because the process is actually trial and error. And then poor generalization. Uh, Reinforcement learning, when we try in the one environment, maybe fail in the slightly different environment. So, for example, a robot in trained in simulation may not adapt well into the real world because the process is learning the environment. So when we have changed the environment, the simulation and the formula that already create the best formula already create in the one environment. When we meet another environment, it cannot be used, and then we have to try again, and maybe we have to make the reward again and keep trying again. And then when we use reinforcement learning, there is an ethical and safety concern because it's a trial and error in the real world can be unsafe. For example, self-driving car and healthcare. And then when we are use simulation is safer, but in the reality is hard. So because the reinforcement learning is about predicting an action in the environment that we don't give a data or something, it can be used to predict. For example, in the business, uh reinforcement learning can be used in the marketing is for personal recommendation. In the finance, is designed for trading and portfolio optimization. In the supply chain, stock management and logistics. In the pricing, it can create a dynamic pricing in the airline. In the operation, it can use for process and energy optimization. In the customer support, it can be a smart chatbot. Okay, for example, the supply chain. There is a lot of way when we are talking about the supply chain. Maybe through this way, and then maybe through the another way, maybe through the fourth way, and then when we use the reinforcement learning, the agent can try each path in the simulation and find the best way to get the supply chain as efficient as possible. That's the example. Again, the conclusion, reinforcement learning is very powerful, but its drawback, safety, inefficiency, instability, and poor generalization make it challenging to apply outside of control or simulated environment. Okay, I guess that's my presentation. If there's any question.
Thank you, sir. Thank you for presenting. A few of our participants have asked a question that what are some real world application of reinforcement learning that we already use today?
Okay, yeah, that's a good question. Reinforcement learning, like what I said, it's okay, wait. Okay, reinforcement learning mostly used in this area, in this area. Finance, trading, trading. We find the environment. We find the environment. Find the environment. And I also ever trading the forex. Yeah. For example, foreign foreign exchange. Yeah, foreign exchange. We use this reinforcement learning for processing. Which one should we buy the US versus US versus Euro, or this one with this one, which one give the best result by processing the environment. There is a lot of process in this in the forex trading. Uh, there is a lot of market in the forex trading. So maybe the computer is try by this one, and then they can predict this is have a better result and compared to this one, not by the data set, but by the trial and error, by predicting by the trial and error. And then what I know is supply chain. For stock management, I have explained before that the the reinforcement learning is uh, very good in the define how the process of the stock management. A lot of way, a lot of cost, a lot of transportation problem, and by simulating this, the reinforcement learning can find the best strategy to do in the supply chain. Same with pricing. Price, maybe for the airline, if airline have a dynamic pricing. Maybe in the vacation the price is like this. In the normal day the price is lower. So because it's about the environment, it's not about the predicting data from the previous data, but predicting the environment. The reinforcement learning can be used for this process. Customer support for chatbot. This is common use in the reinforcement learning. And reinforcement learning, the algorithm is also provided by just like Amazon, just like any cloud provider that provide the machine learning or deep learning process is also provide this mechanism, this algorithm in their product. Okay, I guess that's my answer. That's my answer for Mr. Kurniawan. Is it
Thank you, sir. Thank you for presenting. And I would like to call upon our next speaker,
okay?
Mr. Ramprasad, Security Analyst, Hebesec Technologies, India.
Screens available.
Sir, it's audible.
Good afternoon, everyone. I am here to take an webinar on I am here to take a webinar on reinforcement learning, teaching machines through error and trial and error. Reinforcement learning often called RL is one of the most fantastic and rapidly growing area of unlike traditional programming, where we explicitly tell the computer what to do. RL allows machines to figure out solutions themselves through interacting and feedbacks. Think about it. At human, we don't learn everything from instructions manuals. We learn by trying, failing, adjusting, and trying again. Whether it's learning to ride a bicycle, playing a video game, or even cooking, trial and errors is attached to human learning. RL applies this same principle to machines. Key concepts. Let's begin by understanding the basic mechanisms of reinforcement learning. Reinforcement learning is a type of machine learning where an agent interacts with an environment to achieve a goal. Instead of being programmed with static instructions, the agent learns by performing actions and receiving feedbacks. If the action was good, it gets a positive reward. If the action was bad, it gets a penalty. Over time, by repeating this process, the agent learns which action leads to better results. Here a simple analogy. Imagine teaching a child how to play a new game. You can't give them all the rules up front. Instead, they try different things, and as they play, they learn what works and what does not. This essentially reinforcement learning. The big difference between oral and other AI methods like supervised learning is that reinforcement learning does not rely on huge labeled data sets. It's learned directly through experience. Now, to understand oral better, we need to break it down into its core components. Key components of reinforcement learning are agent, the environment, actions, rewards. Agent, the decision maker, like a robot, a program, or a game character. And the environment, the world the agent interacts with, for example, the road for a self-driving car or a chessboard for an chess playing AI. And actions, The choice that the agent can take at a moment and rewards feedback for an action. Positive rewards encourage repeating and behavior. Negative ones discourage it. Two additional strategic elements help guide the learning process. Policy, the agent strategies or playback that it tells that agent what action to take in each situation. Another one is the value function, a value to eliminate the long-term benefits of an action, not just ultimate rewards. For example, in chess, moving a pawn forward might not give an immediate advantage, but it could help win the game later. The value function helps the agent recognize such long-term benefits. So building block from on a foundation. But the real power of a RL comes from how these parts interact in a cycle. Let's look at the strategic elements and device applications. Learning process in RL is like a feedback loop that repeats over and over. The agent starts in an environment. It observes the current state. It takes an action. The environment responds with a new state and the reward for penalty. The agent updates its knowledge and adjusts its policy. The cycle continues until the agent becomes really good at the task. Think of a dog learning a trick. At first, the dog is confused and tricks random tricks. But when it accidentally sits, it gets a treat. Slowly, the dog recognizes sitting when command leads to the reward. Eventually, it masters the tricks. Reinforcement learning works the same way. Repetition, feedback, and improvement. But many people misunderstood oral. So before moving upward, let's clear up to some common myths. There are three common myths about reinforcement learning. Oral needs massive labeled data sets. Unlike supervised learning, oral does not need labeled data. Instead, it learns directly from interaction, making it ideal with labeled data is expensive or unavailable. Second, oral can solve any problem without human involvement. Not true. Human play a crucial role in designing environment, defining rewards, and shaping the learning process. Without human input, oral might learn the wrong behavior. And the last is oral can solve any problem without human involvement. Uh, oral is only for simple, well-defined problems. In reality, oral is used in some of the most complex domains, gaming, robotics, finance, and healthcare. Its ability to adapt make it well suited for open-ended challenges. Now that we have cleared up with what RL is not, let's dive into the methodologies that guide how RL against actual reinforcement learning approaches can be broadly classified into two. Model-free reinforcement learning. The agent learns purely through the experience without building a model of an environment. Example, Q learning, where the agent learns the expected value from actions. Deep Q networks, which combine Q learning with the deep learning to handle complex situations. Second, model-based RL. The agent builds a model of an environment that uses it to plan ahead, more efficient but hard to implement. Useful in robotics, where predicting outcomes helps avoid costly mistakes. So, depending on the tasks, we choose model free or model based reinforcement learning. But the real question is where the reinforcement learning make an impact today. Let's explore it with applications. So, reinforcement learning is already transforming industries, gaming, robotics, self-driving car, finances, healthcare. These are the real world or where we can use the a reinforcement learning. First, the gaming. Deep Minds AlphaGo shocked the world by beating the best human player in Go, a game once thought impossible for AI. In robotics, the robots learn to assemble products, walk on uneven terrain, or navigate unknown environment. In self-driving cars use AI reinforcement learning to handle traffic signals and unpredictable road conditions. In finance, RL agents optimize trading strategies, making risk and minimize profits and maximize the profits. In healthcare domain, RL helps design professionalized treatment, optimize drug discovery, and assist in robotic surgeries. These real world uses how the versatility of RL, but for all its power, RL is not without serious challenges. Challenges in reinforcement learning. Despite impressive program, RL faces heartless exploitation is this exploitation. Should the agent explore new actions or stick with what already works? For example, do you keep going to your favorite restaurant or try a new one? The, the balance is tricky. The data inefficiency. Oral often takes billions of trials to learn effectively. This is fine in games but costly in real world systems like cars or healthcare. Another major drawback is computational power. Training large RL models require huge computing resources, often only available to big tech labs. And the final drawback is safety concerns. In critical domains like autonomous driving, a single mistake during learning can have consequences. Researchers are working hard to solve this, but their progress is shaping the future of RL. The future of reinforcement learning is bright and obvious. Deep, deep reinforcement learning, combining RL with neural networks, is already solving problems like game playing and robotic control. Smart cities, RL can manage traffic lights, energy use, and resource distribution. Industry 4.0, smarter automation in factories, supply chain, and logistics. Generative AI plus with the help of reinforcement learning. Imagine AI not just learning to act, but also to create involvement and innovative strategies and solutions. These possibilities are endless, and as computing grows stronger, RL will continue to push the borders of what machine can achieve. Now I am concluding here on my presentation. Reinforcement learning is about a machine learning through trial and error. It builds an agent environment, action, and thoughts. It's already involving industries like gaming, robotics, finance, and healthcare. While challenges exist, innovations in deep RL and safer methods overcome, are overcoming them. The future promise smarter, more adaptive AI system. If you are interested in learning more, check out tools like OpenAI Gym for practice. Reinforcement learning gives machines the ability to not just to follow instructions, but to learn, adopt, and improve on their own. Thank you so much for your time and attention. I am concluding my discussion here.
Thank you, Ramprasad. Thank you for presenting. And you have no questions from the participant. So I want to call upon the final speaker, Mr. Sriram, security researcher from Cyber Thulir, Malaysia.
Am I audible, ma'am? Am I audible?
Yes, you are audible.
Yes. Okay. I'm Sriram, cybersecurity researcher from Cyber Thulir, Malaysia. Now I'm going to talk about the topic of reinforcement learning through errors and trends. Just a minute, I will share my PPT. Is it visible? My PPT is?
Yes, Ramprasad. Sorry.
Okay.
Yes, Sriram.
Okay. Okay. We all are come across the term AI and how it is dominating the IT sector and how it is influencing them many departments in IT industry. And we come across that AI models like ChatGPT, Gamma, DeepSeek, and Sora AIs. This kind of AIs are high-level AI models, which is trained by AI engineers and developers. But when we are wondering how this kind of AI is generating the response, but just from our prompts. But it is being developed by this kind of learning methodologies like supervised learning, unsupervised learning, and the reinforcement learning. These three methods. And also, these three methods can vary, depends on the AI model that we are going to train and based on the problem statement we are going to focus. And the supervised learning is mainly focusing on about the labeled data and the labeled output, where we are giving that AI model that we are giving that this is a this is a cat image and its output is the answer is cat. So that model is going to predict that like that. So this is a supervised learning. The unsupervised learning is we are going to give the data at the same time we are not going to tell the output to that particular agent. It is going to learn from the previous learning of the labeled data that we gave. On the other kind, the reinforcement learning is completely different from these kind of trainings, where we are not going to give any labels or outputs to that particular model. We are going to train that model from the scratch itself. Then, okay, now we are going to the topic of reinforcement learning. So it is a sub branch of a machine learning agent where we are here in the sense the agent here mentioning is that the model, AI model, like a ChatGPT or something like that. We are going to mention it like an agent where that particular agent is going to learn about decision making by we are by making a decisions in a simulated environment, just like that. And also we are just like that. I have already told we are not going to give a labeled data set of this is a cat. So we are going to tell that this is a cat image, but it is going to make a errors and learn from it to identify itself. It is going to identify on its own that this is a cat and this is a dog, like that. Then why we are choosing a reinforcement learning? The reinforcement learning is influenced by our humans like nature. Like when we are born, we don't know about how to communicate or how to speak, how to survive, or how to uh, learn to walk like that. We are learning that process by step process and by interacting with the environment. Just like that, this AI model is going to learn by making its own mistakes and things like that. And also, it is dynamic environment. Here, the dynamic environment, what we are going to say is, for example, we are training a AI model in a particular environment and transferring that particular agent only to another kind of situation of simulated environment. It can able to adapt by following the previous the steps decisions made in the previous environment. So it is a dynamic environment where it can adapt to the different type of environment it can face, and it's sequential decisions. The sequential decision means when we are training this model, we are going to give a different types of situations and the scenarios to the agents, where it is going to make a decision. Based on the decision, it is going to get a reward or a penalty or some feedback about that action it made. So it is learning and making lot and lot of decisions. By giving that, the model can train a lot and can give a more accuracy and better solutions to the problems. Then this is a experience driven. Just like that, it is going to make a lot of combinations of decision and making that. So it can learn from its experience. Then the core elements of reinforcement learning. The core elements in the sense means what are the things that we are going to use the model to train, like the agent, that model that we are going to use, that is making the changes in the environment to learn. Then the environment is a space for a agent to learn. Like in the environment may have the objects, some other things to help the agent to learn. And also the state. Here, the state in the sense means um, before making a decision, the agent will have some one state. The state may have the informations about the previous experience and the feedback about that. After making an action, that state will change. Well, like now that agent is taken a action and it get a feedback, whether it is reward or a penalty, it will configure that it will add that data to the agent by making that. Now we make a decision, it give you a reward like that, or if we make a decision, this is a penalty for us, so we don't have to make that same mistake again. Like that, the data will be added to the agent. Under the action, the choice made by the agent in that agent. Then the reward in the sense it is meet the feedback of whether a penalty or a reward. Then this is the learning cycle of a reinforcement model. This is how the reinforcement model will learn. First, the agent will be in there. Then it will have an environment to act, and it will have a policy and the goal. The agent will make an action to that environment to meet its goal. Whether after the action is made, the agent will be feedback with a reward or a penalty, and it will get to the agent. And at the same time, the state will be changed. The based on that action performed, it will memorize the action which it took in this particular scenario, and what the feedback it get will be added to the agent. So this is the learning cycle of an reinforcement learning algorithm, and how the agent is being trained. Then let's say for an example that we are going to for an example we are going to train an agent that that will be present in an environment. The action that is going to taken is it that particular agent needs to learn how to walk in an environment. That is the goal of an agent. And the reward for that agent is to be like points, a numerical value, and the state of the agent will be changed. Just for an example first, First, in this scenario, this is the environment for our agent. It needs to work on that. And this is our agent. And the policy we are that going to say is the agent, particular agent, do not fall on this floor, on this environment. The goal of this agent is to, it needs to learn to how to walk. This is the first goal of this agent. So it will implement this multiple number of times until it learns to how to walk. This is the first scenario of our agent. Then this is the second scenario that we are going to give to our agent. Like just like already it learned how to walk. Then the second scenario is in this particular environment there is going to be walls here and there, and that particular agent need to identify there is some wall in between our destiny, our goal, that green box. So it needs to learn to turn and go to its goal. This is the second scenario that we are going to give to our agent. Now it will take a lot of implementations and to reach its goal of here and there. So in this here situation, our policy is to you need to identify where is the wall and how to turn to avoid that, avoid being hidden by the wall. So this is the scenario of second situation. Now, after learning of walking and turning, now we are going to place some objects in the environment. So but our agent's policy is now is to identify the objects that is blocking our way, need to turn around that object to reach our destiny. This is the third scenario of our objects. Like this, the AI model is being learned by the reinforcement learning of giving different environment scenarios and the goal to that agent. And after completing that process, what kind of reward it is going to take. This is how a reinforcement model is being trained and used in a real world. Then when we talking about reinforcement learning, there is two important things that influence exploration and exploitation. Here, in the sense, exploration means the AI model needs to, whenever it is doing some actions, it will get a reward of for its points, feedback of reward. So that AI model will get to know what are the different ways and the different methodological approach can be used to get many number of rewards. So it will try to find the unexplored or the unexplored methodological solutions to that particular problem. So the AI model will do lot of explorations to get a better reward. And then the exploitation. Here in the sense, exploitation means when for an example, in a previous environment that our agent find a better solution to a particular problem means that will strategize it as a best solution for this particular scenario. In the sense, it will make it. Then in the next situation, when it is facing a same situation like the previous one, it will take the solution from the previous methodology to implement this in this one. So it can increase the knowledge of the agent and need to how, and it will make it to act whenever the correct situation, when you are facing the already faced with this kind of situation. So we can make this decision also. So it will at the same time it will do the exploration and exploitation. So by doing this, the agent, the particular or AI model can get more knowledgeable and uh, make a clear decision at the confusion state. Then mainly the application of reinforcement learning is from the uh, games. Like in 1990s, we all come across the TV games of ping pong, where one person will be standing there and the ball will be floating across the air. So we try to uh, deflect the ball. So in that situation, that particular model will be being trained to tackle that ball. And also the reinforcement learning is highly used in the gaming industries. Like when we are playing some online games, and also for an example, let's say the PUBG and also the other online games, Fortnite, that games like that. In that situation where the players need to fill that lobby like that, when there is a shortage of player, that game server will automatically fill it with the bots. In the sense, the bot means it needs to act as a player, but we cannot just write codes for the bot to just turn around, pick a gun, shoot the opponent like that, because it is dynamic, where it can be that particular bot can be placed anywhere in the games. So at the time we need a reinforcement learning to train that bot to how to walk around, how to identify an object, how to identify an enemy, how to identify a gun, and how to shoot that like that. We need that reinforcement learning is being used in the gaming industry mainly. And also when we use it to play chess in our laptop or computers like systems like that, when the opponent player is most likely be a computer, where in that situation that the application of reinforcement learning is being used, where in chess game that particular agent needs to make lots of decision. Based on the decision it's making, it will get a reward of winning over the opponent. This is the real world application of reinforcement learning. And also here in the sense, the one of the famous algorithm that is being used here is deep Q networks for training an that a bot or opponent player computer like that. Then the real world impact of reinforcement learning, mainly that just like we talked about the example of how to train our model to walk. Robotics is being used the reinforcement learning to make the robots to work. We have come across the social media websites like AI robot is walking and AI dog is trying to robotic or dog is trying to walk. That that is mainly implemented by the reinforcement learning. So the reinforcement learning mainly influencing in the robotics field. Then the healthcare. It may influence the healthcare systems. Like there are billions of peoples in this world we are living, and many of the lakhs and lakhs of diseases are being spread to that human beings, and we are having different immunity and different deficiency to the different diseases. So we need an reinforcement learning methodology to analyze our patient to what kind of drugs and what kind of dosage can be used to cure that particular agent, particular person. And in finance sector, like just like we already thought, in finance sector the stock market prediction may differ drastically change across over the world. In that situation like that, we can implement reinforcement learning to learn the model to in this particular coin rate in this time period, and in what timing now, and in future how it will influence like that. And the autonomous vehicles, just like we already know the Tesla cars, the autopilot mode it is having, how it is making decisions to uh, drive the car. It is mainly fluently based on the reinforcement learning methodology of making a real-time prediction of the traffic light, and also someone is suddenly coming into the car under the speed brake. Based on that, it need to make a decision, but it can only be learned by using the reinforcement learning, and it can be it will be performed in a simulated environment or in a safe location. And and the smart systems. In the smart system here, the means IoT, information of Internet of Things. Then the Internet of Things means like the IoT devices, which will smart homes, smart home technologies of uh, then like buckler alarm, and sound sensor or the camera, and also you have room temperature predicting like that. But when we are applying it in reinforcement learning, based on the data from the temperature that we get from the room temperature, it will act like, okay, it is very warm here, so we need to switch on the AC to make it cooler. So it will automatically switch on the AC like that. And also when we are having a sound sensor like that, when someone is trying to break our door lock means, it will automatically detect the sound from that and turn on the CCTV camera or turn on the alarm systems like that. We can implement the reinforcement learning in IoT based systems also. Then the key advantages of reinforcement learning, just like we have already talked about the adaptive learning, where it can act in different types of environment and different kinds of scenarios and the situation, where it can already went through that particular processes and the decision made in the previous environment, and also it can be able to solve complex problem solving, just like we talked about the exploration. I say one of the feature of the reinforcement learning, where it can make a different situations, solutions, and the unpredicted methodology and the patterns to the problems that we are facing. So it can able to solve the complex problems by making a complex sequential decisions to that particular problem, and it is highly potential and autonomous AI, like it can think and make a decision like that. And also the challenges of reinforcement learning. When we come to the challenges means the high computation cost. Already we know the AI models are being trained by using lots and lots of data, and lots and lots of GPUs is being used for performing the decisions and the combinations to that agent. So it needs a high costing GPUs and CPU capacity and servers for developing an particular AI, and extensive data requirement. Here in the means it might need not need it do not need some label data, but it needs the different kinds of situations and scenarios and the different of objects that is affecting our agents to not making a decision or reaching its goal. So we need a different situation and scenarios to make our agents perfect and able to uh, compute in a different scenarios and in slow convergence. Just like we already talked, it needs to done millions and billions of parameters to make it perform very, very accurate. So it needs some more time, and it is the learning stem is very slow. Just like we already thought, just it needs some time and a step-by-step process of learning. So it needs take a much amount of time compared to other type of learning algorithms. Then the exploration and exploitance balance. Here the exploration and exploitance means, for example, if our agent is only making exploration of finding different solutions, different path for a simple solutions means also it will affect its performance. And the exploitation problem means, here our AI model is only sticking to that particular solution to that particular problem. For every problems, it is sticking to a only its finder solution of not a optimal one or not an efficient one. It is not exploring different situations where these two things are happening at the same time. So it needs to find a right balance of when to explore for a new solution, or and it's need to stick to a defined solution at the same time. So it needs to balance a need of when to explore and when to exploitation. Then generalization limits. Just like we already told, sometimes we cannot implement the reinforcement learning in real worlds, where it's some you need some security parameters and concerns like that. Like the autonomous vehicles, we just cannot simply implement the autonomous vehicles in real world. But that we need to consider the safeties also, and the Tesla's car system, like autopilot, like that. But we need to find and figure out the optimal solution and things for our for implementing the reinforcement learning. Then the reinforcement learning is mainly used in the situations of the gaming industry mainly, and in autonomous cars, and it can be implemented in the IoT based systems. Then thank you.
Thank you, Mr. Sriram. Thank you for presenting, and you have no any other questions from the participant. So thank you so much for all the presenters who presented this webinar. So it's time to finish up today's webinar. So as we conclude this remarkable international webinar, it is a time to reflect on the shared knowledge, connection, and valuable insights gained through the event. Before we officially close, I would like to express our deepest gratitude to all our distinguished speakers and our delighted organizing team and all the enthused participants. Your active engagement throughout the questions and diverse perspective have truly enriched this webinar. Today webinar, it is a powerful of a global collaboration and the incredible potential of technology, the power of global collaboration and everything. So thank you once again for everyone who presented this webinar, and have a wonderful day. Thank you. And once again, um, from the university, STEKOM University, we have posted a attendance link in the chat box. So please have a look. Thank you.